think it might be a calculus because they were taking the final on the same day in Virginia.
Just kidding. Alright, so that's the previous class. Alright. Not only does this thing write certain sums more concisely, but it has certain properties that make it, again, versatile to work with. I'll explain in a second. I just want you to understand what it's saying though. So this in here is called a dummy variable. And it's telling you that n ranges through the values 1 through 10, right? Now I'll write another one here without any n inside here. I'll write the number 2, for instance, and we'll say n equals 1 to 5. Now n is going to start at 1. Then I just start at 1 necessarily. I'm going to start a lot of them at 1. They don't have to. Start at 0. They will not start at negatives in this text. But they could start at higher values as well. So what is this trying to say then? According to this paradigm here, what's that trying to say?
Something between 1 and 5.
Yeah?
It's adding 2 5 times.
Adding 2 5 times. The first thing that this thing does is it writes the number 2. Just like here, it wrote n. But the first n said n was 1. So the first thing it writes here is a 1. But then this moves up, like a tumbler, right? In a sense, like there's a 2. It clicks up to 2. So the next n that I add here is the number 2. It clicks up again. So the next n I add happens to be the 3. Up until we top out at 10. Here, this expression is always 2 regardless of n. But there are still 5 n's,
Yeah,
right?
would you write 2 to the power of n minus 1 to get rid of that 1?
No, what
No, we're adding. We're not multiplying.
Would it be 2
Plus 2
5 times?
That's right. That's what Rosas was saying. That's right. When n is 1, what does this read? 2. And the sigma says then add the next thing. So when n is 2 now, this is 2. When n is 3, it's 2, and so forth. Right? Everything it reads off this time is 2. It's a constant. Right? So this one is 10. This one was 55. 55 was correct, yes? Yeah? Some of the first 10 integers, non-zero integers, is 55, right? All right. We have more complicated expressions. N equals 4 to 8 of, say, some polynomial-looking thing, 3n squared minus 2n. So all you're going to do is plug in 4, right? That's the first one. So 3 times 4 squared minus 2 times 4. That's when n is 4. That's where this is starting this time. Plus, due to the fact that it's a sigma notation, now you're going to add to it. The next one, n is 5, and so forth. So 5 squared minus 2 times 5. Plus the next one, right? Until you get till, what? 3 times 8 squared minus 2 times 8, and you'll just crunch all these numbers together. Okay? You'll find out what the actual summation is, right? So right now, these are all finite summations. You're going to say Rosales?
Isn't there a formula for it?
For what?
Doing all that.
Sometimes. That's what we're going to get to in a minute. That's right. Sometimes there are certain formulas that these things conform to. All right, any question about the notation itself, though, and what it's trying to say?
So the number is like where the 2 is, that's always.
Where this 2 is?
Yeah. That's, if it was like a function, that would be your, I guess that's your function. Okay, and then under it is the increment. No, that's where you start.
And you could say it's where the independent variable starts.
Right.
But it only goes up by increments of 1, right? You don't go to 1.5 or 1.6, right? 1, 2, 3, 4, and you stop at 5.
So with a summation, we're only going up by increments of 1.
That's right.
So we're never going to go up by like a half or something.
Correct.
This.
Okay. Never.
Okay.
Yeah. Right?
N equals the number of increments and moves, right? So 2 to 2.
N equals number of increments and movers?
Answer is 510.
Well, it would be the starting number.
It's not the number of increments we move because we only move 9 increments from 1 to 10 is 1 9.
No, for a second.
Say again.
For the second one.
The second one. N starts at 1. It's still counting something. Just because you don't see it in this expression here inside the single notation, you're going to see it in the function here. There's a constant function. So n is 1. You think of n as like the independent variable in some function inside the single notation. Right?
So if n equals to 2 for the second one, you write 4 twos.
If n had started at 2,
So you write 4 twos.
that's right. That's right. Because you got 2, 3, 4, and 5. That's right. So 4 twos in that case. Okay. What about if you don't see anything in there? It just says this. N equals 1 to 100. What does that mean?
Then n would be 0, wouldn't it?
It's not 0.
And
It's not 0 and 1.
It's 1. That's right. It's 1. It really means this, but they don't write it. You're going to have that sometimes. So you got to know what it means. There's a visible 1 there. So what are you really doing in this problem? You're adding up 1 100 times. So what do you get? 100. That's right. So just in shorthand, right? Equals 1 100 times, and that equals 100, of course. Okay, so no question about notation now. You guys are okay with what it's trying to say. All right, let's develop some formulae for this thing, which we'll use a little bit in this section and will be much more important in the next section. Okay, so formulas regarding sigma notation. The first one is regarding this particular first expression I have here. I would like to do, I'm going to, instead of using n for the dummy variable, I'm going to use I for the dummy variable. I. So the sum of I, as I goes from 1, over here you saw as it goes from 1 to 10, we're just writing out the first 10 integers, positive integers, and adding them together. The first 10 natural numbers, adding them together. Okay? So no matter what I put up here now, if I were to put up here the number 50, then this expression says add up the first 50 natural numbers, correct? 1 through 50, add up 1 through 50. So what we want to do is find out a formula for no matter what you tell me to add up to. Okay? I got to add to 1,000. Okay. I want a formula for that. I don't have to, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. I don't have to do that, it's just too much. Who knows this formula?
It's the late pre-calc, right? Like arithmetic and geometric series.
It's been a while.
Sometimes I bring it up, sometimes I don't.
And they taught us something about the calculator to find a quick answer for that.
You are close. Now you're even closer, but there's still one. Yeah. The formula is this: n times n plus 1, not minus 1, over 2. Okay? That is the formula. So right now, if I wanted to add the numbers from 1 to 1,000 together, I would take 1,000 times 1,001 and divide by 2. Now, since I am multiplying two adjacent natural numbers together, one of them must be even. So one of them always is divisible by the 2 below. So in this case, 1,000 times 1,001 divided by 2 is really 500 times 1,001. And what's 500 times 1,001? 500,000? 500. So if you want to add the first 1,000 numbers, it turns out the sum of the first 1,000 numbers is 500,000, 500.